Okay, g'day students. Welcome to our second lesson in Earth geometry. We're looking at distances on the surface of the Earth today. So we want you to be able to calculate the angular distance in degrees and minutes and distance in kilometres between two places on Earth using the same meridian. So remember, they're going up and down. So they've got to be a great circle. And so we'll use the formula distance equals 111.2 kilometres per degree times the angular distance, which is just the number of degrees. Now we'll also have to calculate the angular distance in degrees and minutes and distance in kilometres between two places on the surface of the Earth using the same parallel latitude, and this is a distance on a small circle. So we're going across, and that's going to be all except for the equator. This will still work for the equator because 0 will equal 1, but it's the same formula as before. But we're just saying, well, the distance in kilometres equals 111.2 kilometres per degree multiplied by the cosine angle of latitude times the angular distance. And then, yeah, that'll do us today. So the first point is that the distance between 2 points at the same longitude, that's on the great circle, so meridians or the equator, is just that it's going to be 111 degrees kilometres per degree times the number of degrees that you travel. So that's called the angular distance. Now the distance between 2 points in the same latitude on the small circle is just the angular distance, so the number of degrees that you travel, multiplied by 111.2 kilometres per degree, and then multiplied by cosine the degree of latitude. Now, if you're going more than 180 degrees, so for example, if you're travelling 200 degrees across the surface of the Earth, chances are you probably can go quicker the other way. So if you're travelling east for 200 degrees, chances are that 360 minus 200 is 160 degrees east. So it's just going to be quicker to go around the Earth the other way. Now the angular distance for same points of longitude on the great circle is it? Let's have a look at this. Let's look at this diagram. So angular distance for same points of longitude, we've got the degree of latitude. So that's that one there. That's that one there. And then this one is our small circle. So a couple of interesting points. If you're travelling between hemispheres, so for example, if I'm travelling from this point here down to this point, I've travelled 30 degrees. But if I go further, I've travelled a total of 60 degrees. So I've travelled 30 degrees there and 30 degrees there. And so that's going to be a total of 60 degrees, isn't it? So you can see that I've travelled there. So 30 degrees north down to 30 degrees south is 60 degrees. So, however, if I'm travelling from here to here, I'm just travelling 30 degrees because I'm travelling 60 degrees north down to 30 degrees north. So if they're on the same hemisphere, so on the northern hemisphere, we're just going to minus the small one from the big one. So 60 degrees take 30 degrees will give you 30 degrees travelled. But if you're crossing the equator, you're going to plus them. So 30 plus 30 will see that you've travelled 60 degrees. We can also cross that international date line, can't we? So we'll have a look at this in a little bit more detail soon, but if I'm travelling from here to here, I'm travelling from 150 degrees east to 180, so that's 30 degrees. Let's try different colours. I'm going from here to here, travelled 30 degrees, and then let's say I'm travelling to somewhere like Hawaii. I've travelled another 30 degrees. That's a total of 60 degrees. So just bear in mind that international date line or the prime meridian over here if you're crossing this as well. So if I'm travelling from here over to here, I've travelled a total of 30 plus 30 plus 30. So that's a total of 90 degrees. Okay, so when we want to calculate the distances on the surface of the Earth, first of all with great circles, so remember our definition of a great circle is the equator or all the meridians. So we want to calculate the distance between 42 degrees north and 50 degrees north, but we're travelling along the same meridian of longitude, which is 12 degrees west. So that's like over here somewhere. So or maybe a little bit further, about there. So we're just travelling directly, well, going from 42 degrees north up to 50 degrees north. So we've actually travelled a total of 8 degrees. What we just need to recall is that our distance then is in kilometres is our angular distance of 8 degrees times 111.2 kilometres. We can even say per degree. And that will give us a total of 889.6 kilometres. Let's have a look here. What if we're travelling from 42 degrees north down to 50 degrees south? So we're still on the same meridian of longitude, so it's a great circle. So we're going to have to add those two distances together. So we're crossing the equator. So we're visualizing, well, that's 0, so 12's got to be over here. Perhaps about there, down to 50 degrees south. Well, that's 30, so let's go traveling from like there to there. So you have to add them together for a total of 92 degrees. So you've got 92 degrees times 111.2 kilometres per degree, and that'll get you a total of 10,230 kilometres. Now, if we're looking at distances on the surface of the Earth, but we're looking at small circles, we're looking at going across the surface of the Earth, but not the equator, because the equator is a great circle, recall. So let's have a look here. We're at 42 degrees north. So, well, that's 30 and that's 60. So it's around that line somewhere. And 120 degrees east. So that's 120. So that's about there. And we are going to go to 70 degrees west. So we need to just consider where we are. So that's 90, that's 60, so about a third of the way, so probably about there. So we're travelling from there to there. Now we're on the same meridian, and you can tell we're on the same meridian because, we're on the same side of the Greenwich meridian, yes, so that's the prime meridian of the Greenwich meridian, and we are still at 42 degrees north. So we're travelling, what's this, from west to east. So we're travelling east. We're travelling east 50 degrees, aren't we? So I just said 120 take 70. That's a total of 50 degrees. So 50 degrees now times 111.2 kilometres. But because it's a small circle, we'll need to just put in this cosine 42 degrees. So it's 50 degrees times 111.2 cosine 42 degrees will give us a total of 4,131.89 kilometres. A second example is, what if we're travelling now 42 degrees north, 120 west, so we're up here somewhere, and it's about there, and we are travelling to 70 degrees east. So we want to, well, there's 60, there's 70, and we want to travel around about there, so the middle of Russia. Now, they're on opposite sides of the Greenwich meridian, so is it going to be quicker to fly that way or quicker to fly that way? So let's plus them first of all, because they're on the opposite sides of the Greenwich meridian. So 70 plus 120 is 190 degrees. Now 190 degrees is greater than half a circle, which is 180 degrees. So it's going to be quicker to fly the other way. So to cross the date line and do it that way. And so we've travelled 170 degrees, and then we're just going to multiply that 170 degrees, which is our angular distance, multiply it by 111.2 kilometres, then put in the cosine 42 for a total of 14,048 kilometres. Okay, now it's worth looking at a local area map because we're going to have to be dealing with degrees, minutes, particularly for our syllabus statements. So if I have a look at the Theodolite Creek boat ramp, you can see that I've located it on the map already. So that's this area here. And if I want to read the north-south coordinates first, so that's latitude, I'll have to look at the scale on the left-hand side. You can see that's 25 degrees, 0.4, is it? 25 degrees, 0.45, 25 degrees, 0.5. So that's 25 degrees in 5 minutes, 25 degrees in 4 minutes. Now we've got something like 4.5 minutes here. So we've just indicated our latitude as 25 degrees and 4.5 minutes south. Now likewise, you can read the scale along the bottom. So we've got 152 degrees and 32.5 minutes east, and that's 152 degrees and 33 minutes east. So each one of these must just equal 0.1 of a minute. So we can then just place in our coordinate for Theodolite Creek boat ramp. Now imagine there's a boat out here somewhere. I've just put in a straight line across because that's a simpler way to look at it at the moment. So this boat is just on this line here. So we have kept the same angle of latitude, but we have to change the angle of longitude. So we're at 152 degrees and 34 minutes east. Now to calculate the angular distance, we can just put that into our calculators and just use that degrees, minutes and button second, degrees, minutes and seconds button I should say, and we'll end up with 1 minute and 18 seconds difference. Now you'll notice that I've just haven't really mentioned seconds before, so what you can do is just press that degrees, minutes and seconds button together to get it back to decimal degrees. So 1 minute and 18 seconds is like saying 0.0216 degrees. Now we can just find the distance in kilometres, which is the distance along a small circle because we're going across. So our distance for a small circle is 112 kilometres times the cosine of the angle of latitude times the angular distance. So we've got 112 kilometres per degree. We've got cosine now, it's my angle of latitude, so the one across here, so I have to read from this side, and then times 1 minute and 18 seconds. Now I could have put this number in as well and got the same answer, and that will give you 2.18 kilometres. Now I think a question like this, finding the distance from Bundaberg to Darwin, is quite challenging because I'm just going to give you a set of coordinates and you're going to have to visualise this. So for example, I've got Bundaberg at 24 degrees and 52 minutes south, 152 degrees and 21 minutes east. Darwin at 12 degrees and 27 minutes south, 130 degrees and 50 minutes east. Now you can see I've removed the seconds because your syllabus does not require you to think about seconds. Okay, so we've got a picture here. I know that Bundaberg is down and to the right, so it's southeast of Darwin. So we've just drawn a line. First of all, we're just going to think of this as a triangle, and then we can find the distance along the bottom line of latitude, for example. I could do the top, but we'll do the bottom. And so just the difference in the east-west coordinates. So I just, into my calculator, type in 152 degrees and 21 minutes and take away 130 degrees and 50 minutes. And that should get me 21 degrees and 31 minutes. Now to find the distance in kilometres, I just need to apply the small circles rule, which is 111.2 times the cosine of the angular latitude times the angular distance. So that will get me 2129, so 2,129 kilometres. Now I can find the difference in longitude too. Now that's going to be a great circle because I'm going north-south. And so I'm just going to do the minus in my calculator to get to 11 degrees and 54 minutes. And then I'll just multiply that by 111.2 kilometres to get 1,323 kilometres. So I have now drawn the triangle, I've found the angular distance, I've found the distance in kilometres. I can just apply Pythagoras' theorem to suggest that the distance between Brisbane and Darwin, along this line here, is 2,506 kilometres. You can have a little bit of a practice with these and then have a go at the mastery questions when you are confident that you can calculate the angular distance in degrees and minutes as appropriate between two places on the surface of the Earth using the same meridian, and the distance between two places on Earth using the same parallel. That's when we use our cosine, because that's a small circle.